So let's start about patch normalization. Patch normalization is one of the most widely used best practices in training the deep learning network. So what is the significance of it? The significance of this layer comes when you are training your neural network with gradient descent, for example, or any variation of the gradient descent. So the gradient value tells us how to update each parameter, which is good. But this is under the assumption that the other layers do not change. And this is not the truth. Basically, when you are training the neural network and when you are updating all the weights, you are updating all of them simultaneously. So each layer is basically has an assumption of the input that is fed to it. So when you are changing all the weights of the network simultaneously, it is as if like each layer basically will behave basically as chasing a moving target forever. It has an assumption of the input, but this assumption is not true always. So we call this the internal covariance or covariate shift. This occurs when the distribution of the activation of a layer shifts significantly through the training. So what is the solution for this? Basically, the patch normalization. When you are feeding a many patch to the network, after each layer, you are standardizing the input using some mathematical equation, very similar to the standard normalization. So basically, what is the benefit of this? It reduces the number of epochs needed to converge and also stabilize the training process. Where to add this patch normalization layer? This is an order that I usually use: convolution, then activation, then max pooling, then patch normalization. For the fully connected layers, it's dense, activation, patch normalization, then dropout. If you search on the internet for the better order, you will find a lot of advices. There is no consensus in the deep learning community on the best order. So you need to find your way for each specific problem. But this is a good start. This is a good order to start with. So let's see how we can use the patch normalization in Keras. First, you need to import it here from the layers package. Then, as I said, we will add it after the max pooling. You don't need to specify any parameter. And in the fully connected layers, you need to specify between the activation and after the dropout. So, and after the activation and before the dropout. That's it pretty much. That's it.